Hi, I'm Vijay. I will be presenting our work on enhancing language model agents using diversity of thoughts. Large language models have shown remarkable potential in tackling complex tasks, but their ability to generate step by step reasoning remains crucial for improving performance. System 1 based prompting techniques like in context learning, chain of thoughts, and their variants are limited in their ability to handle challenging reasoning tasks like mathematical reasoning and code generation. System 2 based reasoning frameworks like LATs have been proposed to address these limitations but are expensive. Reflection is one of the early reasoning frameworks for language models based agents. Briefly, for a given task, a trajectory consisting of an action or text is generated using an actor agent. This trajectory is then evaluated using an external environment or an LLM. A self-reflection agent is invoked if the evaluation fails. This cycle repeats until a stopping criterion is met or the maximum number of iterations is reached. Language agents tree search, in short, LATS, imposes a Monte Carlo tree search to improve decision space exploration. We conducted a post-mortem analysis of the self-reflections generated by LATs by passing them to an LLM. Upon closer inspection, we found that many of these self-reflections were repetitive and redundant. The red and blue color coding highlights the repetitive segments. We scaled our analysis to a subset of problems from the HumanEval dataset, leveraging an LLM to cluster reflections. As shown in the table, while the total number of reflections can be large, only a few are unique. This suggests that LATS frequently generates similar self-reflections, restricting its exploration of the decision space. Additionally, we conducted a quantitative analysis by projecting all generated self-reflections into an embedding space and computing the average pairwise cosine similarity. Our findings indicate that both reflection and LATs exhibit high redundancy in their generated self-reflections. Motivated by this observation, we posed the following research question: can eliminating redundant reflections enable efficient decision space exploration? To address this, we introduced two complementary contributions. One, diversity in reflections, a method to enhance variation in generated reflections, reducing redundancy. Two, task-agnostic memory bank, a mechanism for storing and reusing diverse insights effectively across different tasks. Our framework begins by initializing an embedding model and an empty task-agnostic memory bank. Code generation workflow. For a given task, an actor agent generates a code snippet and evaluates it against unit tests. If it fails, a diverse reflection module generates k diverse reflections. Each reflection and the incorrect code are passed to the actor agent to generate multiple candidates. A potential candidate is selected based on the number of unit tests passed. This process repeats until all unit tests pass or the maximum iterations are reached, mimicking a greedy breadth first search. In phase 1, referred to as DoT, we iterate over the dataset, flagging tasks that fail unit tests. Successful trajectories are stored in the memory bank. In phase 2, dubbed .bank, we focus on flag tasks, dynamically retrieving k-relevant trajectories from the memory bank using cosine similarity. These insights are injected as context into the actor agent to guide decision making. This two-phase process enables efficient decision space exploration and improves task solving performance. We explored two methods for generating diverse reflections: one-shot sampling, where all k reflections are generated in one shot; iterative sampling, reflections are sampled repeatedly by conditioning on previous generations. We evaluate on four benchmarks spanning across programming and reasoning and log either pass at k or 0-1 accuracy. On the HumanEval dataset, we evaluate using visible unit tests and report pass at 1 on hidden test cases. Notably, DoT is up to 20 times cheaper than LATs while delivering superior or competitive performance. We notice similar gains on MBPP using synthetic unit tests. DoT variants are cost effective and offer superior or competitive performance. A similar trend is observed on the LeetCodeHardGym benchmark. In conclusion, we introduced DoT, a novel reasoning framework that diversifies reasoning trajectories and leverages a task-agnostic memory bank for enhanced exploration. Our extensive experiments validate DoT's effectiveness, setting a new state-of-the-art on LeetCodeHardGym with gains of up to 12.5% while remaining cost-effective. Drop by our poster to learn more about DoT.